Okay. This is Vishnu Priya, Assistant Professor from BA Economics program. So today I am just going to discuss about the correlation topic. So why did I choose this topic, correlation? So correlation is more related to economics. First, let's just get into this topic and see what are all the things that are really going to be useful for economic students, right? Correlation analysis. Correlation is basically nothing but the association between two variables, two or more variables. Association in the sense the relationship between two or more variables. In certain cases, it also aims to attempt to find the degree of relationship between two variables. Degree in the sense how far it is associated, how much it is related to one variable is related to another variable. So this is what is being captured by the correlation analysis. And A.M. Turtle rightly put it that in the right words, that is, correlation is an analysis of the covariation between two or more variables. You will see that especially in the computational method, when you are going to find the correlation, you will see that to find the correlation, covariance, finding covariance is very important, and it's one of the important steps in finding out the correlation. Fine, you right now know what is correlation. Now let's move on to the different concepts under this correlation analysis. Why correlation analysis is relevant or crucial in economics? So you all will be wondering, as an economic student, why should I read about this correlation? So it is somewhat, it's always there in the mind, like this is a concept which should be studied only by mathematics students or statistics students. But correlation is very relevant and crucial in economics for mainly this reason. Whatever be the analysis that you are going to do, for example, now you wanted to see whether there is a relationship, whether there is an association between GDP, that is gross domestic product, that is national income of the country, and how the life expectancy or the educational aspects of the country is taken. You wanted to establish the relationship between this GDP and the educational attainment. How will you do so? How can you establish the relationship? You need to first check whether there is some, always when you are going to do some analysis, you need to check whether there is some, whether we can establish some correlation, whether these two variables are correlated or not. Right? This is the first question that we will ask whenever we are going to undertake a research question. Whenever you wanted to prove something, you need to know whether the two variables are correlated or not. Either you take any analysis in economics like GDP, consumption and savings, consumption and income, you wanted to see whether income is influencing the consumption pattern of the individuals, because you know in the current era, not only the income determines the consumption levels, because almost everything is available to us at the credit. Before, in ancient days, whatever the money that we earn, only out of that we are able to get it. But now, since there is an EMI concept, some even which we cannot afford right now can also be bought by us. So your research question is how far this income is influencing the consumption pattern of the consumers, right? So in these cases, you need to know what is the correlation levels, how far one variable is related to other. Only then you can proceed to the next step in the research. So that is why especially you take inflation levels, you take unemployment levels, whatever the variables that you are going to analyze, this correlation will come in handy. That is why it is becoming more and more relevant and more important in economics for you to carry out the research. That is why as an economics student, you need to know what is correlation analysis. Often we tend to get confused between correlation and regression. What do you mean by this correlation? As I rightly put it in the previous slide, that correlation is nothing but the association between two variables. But most of us do mistake regression as such. But there is a minute difference which you need to make it very clear. One is correlation is association between two variables, whereas the regression is studies the impact of independent variable on dependent variable. You know what is, you are choosing what is going to be your independent variable, you are choosing what is going to be the dependent variable. You are going to see, for example, let's take an example of the same example of consumption and income. Now let's take the consumption as a dependent variable, income as independent variable. Now you are going to see how this income is impacting the consumption levels, right? So you are choosing what is going to be your dependent, what is going to be your independent variable. So that is the regression, where you are going to study the causal relationships. That is different. Correlation is where you are going to see whether these two variables are related or not. That's it. That's what you do in correlation. The second difference is no difference in variable. For example, there are two variables, price and demand. You can interchange in correlation. For example, you can, in the first instance, you are taking X as price, Y as demand. Maybe in the second time when you are going to do a correlation analysis, you can interchange the variables, Y as a price, X as a demand. So you can do that. There is no difference in variables, but whereas in regression you can't do so. Both independent and dependent variables are different, which means if at one instance if you choose income as your independent variable and consumption as your dependent variable, for sure throughout the analysis you have to stick to that. It is both the variables are different, right? So next is helps to constitute the connection between two variables. Like I told you, in the research, if you want to ask any research question, you have to address certain problem. First, you need to establish some level of relationship between two variables. For example, taking two irrelevant variables, taking two unrelated variables is not going to help us. For example, when I am discussing about academics, when I am discussing about studies, speaking about the cultural aspect, speaking about some fun activities is not going to make any sense. Taking, for example, academic performance is equal to cultural aspect or any other fun activities. How it is going to determine academic performance? Academic performance as a independent variable and educational attainment and your socio-economic background, the number of hours you dedicate for studying. So these are all the relevant variables. Definitely there will be some correlation between academic performance and the number of hours you daily dedicate to studying, right? So if I am going to randomly select some variable which is not at all related to academic performance, there is no correlation. So for you to establish a relationship, for you to proceed with the research question itself, you should know whether these two variables will be correlated in some sense or not. So that is the third point, that is it helps to constitute the relationship between two variables. Next, helps to estimate the dependent variable's value given the independent variable. In regression analysis, once you know the income levels of the consumers, you will be able to find out the consumption of the consumers. Let's say, for example, the income of a particular consumer is 1 lakh per month. You can substitute in the equation that 1 lakh. When you substitute 1 lakh in the equation, you will be able to arrive at what is the consumption level of the consumer. With the independent variable given, you can always find out the dependent variable's value in case of regression. But in case of correlation, you can't do so. You can just stop till the level of finding an association between the variables. After that, you cannot go and do a mathematical operations, or further you cannot go and finalize the result. Next, in a similar manner, you cannot predict anything in correlation. You cannot predict because of the income. Only the consumption changes. You cannot come to a conclusion. You cannot you cannot predict something. For example, because of this factor, the inflation rates are higher in the economy. You cannot predict anything. But whereas in case of regression, you can always predict for what reason the inflation levels are higher in the economy. You can predict your inflation levels. Maybe in the future, maybe in 6 months time, maybe in 1 month time, the inflation might be at 6%. How can we predict? By doing this regression analysis instead of correlation analysis. So these are the major differences between correlation and regression. Again, I'm stressing this because often most of us do get confused. When we are doing correlation, why we need to go for the regression analysis? Regression is totally a complete thing where we dig in and do a regression analysis for finding out the impact of the independent variable on dependent variable, and we predict, for example, how much the demand for my product will be there in 2030. So these kind of things can be captured or done by this regression analysis, but it cannot be done by the correlation analysis because it just seeks out the association between the variables. As we are discussing about the types of correlation, so now there are many types of correlation as such. So first type is positive correlation. So in case of positive correlation, if you take, whenever the two variables move in the same direction, very good example, for example, price and supply can be given as an example, because price and supply move in the same direction, because as an economic student, whenever the price increases, the demand, the supply also increases. There is a positive relationship between price and supply, right? So both the variables price and supply move in the same direction, which means the two variables price and supply are positively correlated. Positive association is present between these two variables. So that is why that has been given as an example for positive correlation. Next is negative correlation. When you speak about this negative correlation, the two variables move in the opposite direction. Opposite direction means, very good example is price and demand, right? Whenever price increases, demand decreases, or whenever price decreases, demand increases. So there is an inverse relationship between these two variables, or negative relationship between these two variables. You know very well, there is an inverse association between these two variables. That is why sometimes this negative correlation is also known as inverse correlation. Next is linear correlation. In case of linear correlation, if the plotted points are approximately on a straight line, when the ratio of change between the two variables is constant, especially, for example, the very good example we can take is savings and earnings. According to your income levels, the level of savings will differ. The proportion of savings will differ. So automatically it is going to be the same throughout the year. Till your income changes, your saving levels will also be the same. So in these kind of cases, when you plot both the savings and the income data, you will get a straight line. That straight line represents that it is linear in nature. That is, the ratio of change between the income and savings is the same. That is why it comes under linear correlation. Next is non-linear correlation. So if the amount of change in one variable does not bear a constant ratio of the amount of change in the other, whenever it is not constant, whenever it is not a straight line, it is known as non-linear correlation. That is curvy linear correlation. So we can give n number of examples for this non-linear correlation, because not always all the variables are linear in nature, right? So for example, if you take GDP, educational attainment, academic performance, and the number of hours you put to study, demand, price, not always it is going to be linear in nature. Sometimes it is curvy linear in nature, because it is not constant, it is not proportional. You will not consume, for example, income and consumption, if you take, it is not straight line, because the entire income you are not going to spend on consumption. The more and more income increases, the more and more you consume, but after a point you know that you will not consume as much as the increase in your income. So definitely the proportion will not be the same. The proportion is going to reduce. So that is why in certain cases this non-linear correlation or curvy linear correlation will be observed. Next is simple correlation. In simple correlation, when we study only two variables, the relationship is simple correlation. So the very good example is price and demand, price and supply. Here we are dealing only with two variables, simple, right? So that is why it is known as simple correlation. Multiple correlation, here we study more than two variables simultaneously. We know that when we are going to find an equilibrium price and equilibrium quantity in the market, we are going to find, we are going to consider both supply and demand factors, right? We will be concerned about price, demand and supply simultaneously. Simultaneous clearing of markets will happen only when the demand and supply is going to be equal. So you consider two components here, both price, supply and demand. So when you are going to deal with more than two variables simultaneously, it falls under the category of multiple correlation. Now Next is partial correlation. So the study of two variables excluding some other variables. We do this in economics sometimes. For example, we study supply, price and demand eliminating supply side, or sometimes price and supply alone eliminating demand side. We are concerned only about demand, means we eliminate the supply side. We are concerned about only the supply of factors of production, we completely eliminate the demand side, that is consumer's perspective. So when we are concerned only about the producer's perspective, we eliminate consumer's perspective. When we are concerned about consumer's perspective, we eliminate producer's perspective. So these kind of instances we often come across as an economics students. Next, total correlation. Total correlation. In total correlation, all the facts will be taken into account. Every single detail. For example, price, demand, supply, all the facts. You find a correlation for all at once. That is total correlation. Next is perfect correlation. If deviation in one variable is followed by corresponding or proportional deviation in the other. For example, there is a perfect correlation. For example, one variable is perfectly correlated with each other. What does that mean? The proportional deviation in one variable is exactly the same as the other variable. So that is what is known as perfect correlation. There are especially two methods for finding this correlation. One is scatter diagram, next is computational methods. So as far as this scatter diagram is concerned, by looking at the graphs, by graphical method, when you have a data in your hand, when you plot the data, you fit a line. From the line which you have got, from the graph, you can actually infer whether it is a positive correlation or negative correlation or partial, total, or whatever it is. You can actually infer from the graphs. But in case of computational methods, Carl Pearson is one such statistician who came forward and said that we can actually compute and find out the correlation in a different manner. So I am not getting into Carl Pearson's correlation coefficient right now. We will just stop at scatter diagram. Now I am going to show you how different scatter diagrams look like. Now the first case is positive and negative correlation. Perfect positive correlation means the correlation coefficient will be R is equal to +1, which means when R is the maximum, -1 to +1. The correlation coefficient will lie only between -1 to +1. When it is +1, there is a perfect positive correlation, which means the two variables are perfectly related but in a positive manner, which means when one variable increases, the other variable also increases, though the line will be upward sloping. In case of perfect negative correlation, when you consider this, one variable will be moving in one direction and another variable will be moving in the other direction, which means R is equal to -1, which means it will be downward sloping in nature. The very good example is price and demand. When price increases, the demand falls. So the same example you can apply here. Next is high degree positive correlation. High degree positive correlation means this is high degree positive correlation and that is low degree positive correlation. What can you infer from the graph that has been given here? If you look properly at the graph, if you observe the graph more clearly, you will see that the high degree positive correlation is flatter in nature, whereas the low degree positive correlation is steeper in nature, which means it is positively correlated but not that deep. So you can actually identify whether there is a high correlation or less correlation between the variables based upon the graph that you have fitted. Next is, in the similar manner, you can identify whether it is a high degree positive correlation or negative correlation, or it is a low degree positive or negative correlation based upon this. If you observe high degree negative correlation, you can see the line is flatter in nature. In the similar manner, if you observe the low degree negative correlation, it is steeper in nature. So which means that the two variables are associated, there is a high level of correlation negative correlation between the two variables in the first graph, whereas the correlation between the variables is lesser in the second graph. Next, this is linear correlation and curvilinear correlation. If you look at this, linear relationships will always be a straight line, which means there will be a proportionate or constant change in the variables. Whereas in curvilinear relationships, it will be curvy in nature, which the line, when you get the data and you plot it, it will look like a curve in nature, which means the very good example for this curvilinear relationship which you can give is environmental Kuznets hypothesis. You know that it looks like an inverted U. There are many variables in economics which you can actually say it falls under the category of curvilinear relationships. For example, when you are going to plot the investment and the production level, when you are going to plot the income, consumption, savings, income, whatever it is, most of the time you will observe the curvilinear relationship between the variables. So I hope you found this correlation topic interesting. Thank you so much.